All right, we're going to begin. Good afternoon, Computer Science 2A. So, yesterday morning you were half asleep, and tonight's the same. Long day? Or just tired? If you're just tired already, I don't know what you're going to do when it's end of the semester, because the work hasn't started yet. All right, so what are we doing today? We're going to have a look at Lecture 1, which is elementary Java programming. So we've discussed a lot of concepts in this lecture already. We just need to formalize a couple of things, and then we'll have a look at those again in the tutorial tomorrow or tonight, depending on how far we actually get. So what we're going to have a look at is looking at identifiers, types, constants. Same thing that you've seen in C++. What are now the rules inside of Java? Java data types, we spoke about this briefly when we looked at Java and C++ compared. Java has fixed data types. What that means is when we use that data type on any Java virtual machine, it will always be the same size, regardless of what operating system you are currently using. Operators and numerical type conversion, something similar in C++. And character data, that's going to be something new inside of Java that you haven't seen inside of C++. It is there, just haven't had a lot of exposure to it. Output and input, we already done output, system out, but we'll have a look at something else. And then we'll look at all of those sort of concepts in a different type of hello world. Then we'll look at some logical programming constructs, the logical operators, conditional statements, etc. And then we'll see how much time we have left to actually look at some code again. So in terms of the basics, we already covered this very briefly during the practical lecture on Tuesday. We have Java code written in .java files, and we have to make sure that the name of the outermost public class, when it says outermost, that's going to be an important term when we get to working with advanced object orientation and we start learning about inner classes. So an outer class is the outermost class, is the class that appears at the top without any nesting. That has to match the name of the Java source code file. We saw that was a problem. If you don't name it correctly, the compiler tells you it's a problem. This class should be in a file named so-and-so. So you have to make sure that actually works. Once we have Java source code, we can then run the Java compiler. The Java compiler will spit out a bunch of class files. Class files are Java bytecode. So it compiles it to bytecode, and bytecode gets interpreted on the Java virtual machine. So we use Java C for this, and then we use the Java program to run. When you run with the Java program, just specify the name of the class, no .java, no .class at the end, just the name of the outermost class. Yes? So question was, if you couldn't hear, is there any significance to why does everything have to belong inside of a class? And there is. There's a very big underlying concept which we'll talk about when we get to object orientation. First object orientation lecture, we'll talk about this in more detail. But the way Java works is not the same way as C and C++ works. C++ is based on C. C did not have classes. So it's perfectly fine to just write methods. I would say, sorry, not methods, functions. Functions in the middle of nowhere. What's the difference between a method and a function? Most of the time, we think of them as the same things, but there's technically a difference. A method is a function within a class. Functions are standalone. They don't belong to anything. So you can think of that main that we write, it's a main function. Technically, it's a main method because it does belong to a class, but if you look at something like C and C++, it's a main function. It doesn't belong to anything. We don't need to create an instance of something to run it. When the program is created, that's the first thing that would be called. We can pass command line arguments the same way we can with C++. We just call it after the parameters we specify for our Java command. So if we say Java hello world, whatever we pass afterwards, excluding the special options we can pass as our command line arguments or command line argument parameters for our Java call, we can pass command line parameters as well. Identifiers, types, and constants. So identifiers is any sort of thing that you are going to name. So that could be variables, it could be class names, it could be interfaces, it could be enumerations. All of these things require names. Obviously, there are some rules. You can't just have any name. You have to have names that conform to these rules. Obviously, they can't be keywords. So you can't have a class called if, because that's a keyword. You can't have a class called for, because that's a keyword. You can't have things be true, false, or null. Those are also keywords that have specific meaning. What we can do is can consist of letters, digits, underscores, and something interesting here, dollar signs. Now, while it says it can have dollar signs, doesn't mean you use dollar signs. Dollar signs, as you'll see when we get to working with those inner classes, it means something special in the world of Java. But other than that, letters, digits, underscores, perfectly fine. It cannot start with a digit. So there's special rules that say you cannot start an identifier with a digit. You cannot have the digit 0 and then a name of a class. It has to be a letter first and then digit afterwards. Cannot be a reserved word. Now that's an interesting one because there are some words that are not keywords, but they're reserved words in the language. They just haven't been implemented yet. So when you write Java code, most of the time, the things you'll be using for names will be following a certain standard. At least when I show you it, I'll be following a standard where we won't run into that problem. But maybe when you're writing your own code in your own time, maybe you're not following the standard, maybe you're just trying something out, and you might run into a problem when you name things like auto. So auto, might remember from C++, there's no auto in Java, but it's a reserved word. It might be available in the future. So you can't name a variable auto because it's a reserved word. So we talked about true, false, and null. And then the last point there, it can be of any length. Now, that doesn't mean you must abuse the fact it can be any length. Don't name your variables all single characters. Would you write a program where all your variables are named A, B, C, D, E, F, etc., and then you go to 2 letters, A, B, B, C, D, etc.? Would that be easy to read? No. But then you don't do the opposite of that and have 40-line character identifiers. So 40 characters for a single identifier, or 50 characters, or 60 characters, or 100 characters. Then you go into the other extreme where it's too much to read, and that's also going to make your code very difficult to read. So obviously there's a sweet spot in between. There's different coding styles you can use, and depending on the coding style you have, there's ways you can achieve certain information. So some coding styles might say that you start off, the first letter should indicate what type it is. So you could say the first character or first 2 characters for an integer will be I. For an array, it will be A, lowercase. And then you put that and then the rest of the name of your variable in camel case. There is another convention where you write out the name and then you put the type at the end. Name string. Something like that. It all depends on what convention you follow. Now be consistent. Choose one and stick with it. Don't try and mix it together. It's not going to work. So with Java, we either have something called reference types. Reference types pointer. We're not dealing with pointers ourselves, but internally how they actually work, they are actually pointers. Or they're going to be fixed length primitive types. And what does fixed length primitive type mean? We'll see on the next slide the different types that are available in Java. So you'll see there's Boolean, which we use bool in C++. That indicates true or false. Now, for Boolean, there is no real storage size defined for it. It doesn't say exactly how many bytes it takes up. And then there's something called a wrapper class. So we'll talk about that in just a moment after we go through the rest of these. And then there's also something called a suffix. Suffix, something that goes at the end. Prefix, something that goes before. Infix, that's something that comes in the middle. So suffix comes at the end. So we'll talk about that when we get to the numbers at the bottom. You'll see there's suffixes at the bottom. So then we have byte. If you look at byte, you can see it's 8 bits. No matter where you run your Java program, you know a byte is going to take up 8 bits. Characters will take up 16 bits. But note the range. Byte is from negative to positive. Character is from 0, only positive, doesn't go negative. How did you work with negative and positive in C++? If you want to ensure a variable can only be, a number can only be positive, what did you do? Anyone? Unsigned. Unsigned int, unsigned char, unsigned long. Use unsigned. But in Java, you have no choice. If you look at all the number types, negative is part of the range. You cannot change that. That's one thing that a lot of people, when Java came out, were very confused. How do I do unsigned types? Because if you have a situation where you have a limited amount of space and you need to do negative and positive, it's a smaller range than when you only can use positive numbers. So there's short in int. So short is still 16 bits. Note it does go the full range, whereas char goes 0 to 65535. Int is 32 bits. Long is 64 bits. And then you get to float and you get to double. Now float and double, you can see there, float is known also as a single precision float. Single precision meaning how many bits it has available to indicate how big or how small that number can go. Double means double precision, which means more bits it can use for, again, how big or small that number can go. And then the last thing there is something called object, or an object reference. With that, there is no range, because an object reference is a pointer. A pointer is a memory location. So there is no value we can assign. We can only assign it to references that we have or null as no reference. Here it is 32 bits, and it doesn't have a wrapper class because it's a pointer. Depending on what point it points to will be the thing it works with. And we'll talk about wrapper class in a moment. And again, it doesn't have a suffix. So with wrapper classes, you can see the name of the wrapper class is basically the name of the primitive data type. The reason why we have wrapper types is for doing some conversions. So for example, you have in the integer class, you have a pass method, which will pass a string and will convert that string into an integer. The same thing is available in double. You have a method available in that class that can take a string and convert it to a double value. If it works. If it doesn't work, get back an error and you have to deal with it. Other things it might be able to do is convert between different types. And also, it might be able to output in different formats. So you can have, for example, the integer class displaying something in hexadecimal format, or in binary format, or in binary coded decimal. So there is methods available that allow you to do those different things. Then as far as the suffixes are concerned, it's basically a way for us to write a number and tell the compiler it has to be this type. Because if you write the number 1, what is that type? If I just write the number 1 inside Java code, what is that type? Or let's say C++ as well. What is that type? By default, what is that type? It's an integer. You didn't specify anything else, it's an integer. So if I want to say I want to have 1, but I want it to be a float, I put F at the end. So then it will identify as a float. I could do 1.0, but 1.0 by default is a double. So I have to specify F at the end for floats. Same thing for longs. If I don't specify anything, it's an integer. But if I do specify the L there, it will then be a long. Next section we come to is operators and numerical conversion. And then you can see the top, it does say that there is similar rules available in C++. Since we don't have any operator overloading, we only have what's available by default with the numbers. You can add numbers together, you can do a plus there. But if you create any of our own classes, we cannot overload any operators. If we have any sort of conversion that takes place, it happens in the following order. If we have two numbers and we're trying to do an operation on those two numbers, if one of them is a double, the other one will get converted to double, your answer will be a double. Because that is the biggest, and when I say biggest, it means the number of bits that we're using, that's the biggest type. If we have something in a float that's not a double, then it will get converted to a float. If we have something that's not a float, not a double, and is a long, it gets converted to a long. And anything else is going to get converted to an integer before it does that specific operation. You can do manual casting. This is automatic. So if you have, for example, 0.1f plus 2, it takes that 2 and converts it to a float, because 0.1f is a float, plus 2 converts that to a float, and your answer will be a float value at the end. You can do conversions yourself manually. You can explicitly say, I want to convert this thing into a double, or I want to take a double and make it into a float. Now, if you go from a small data type into a big data type, no problem. If you take a float, convert it to a double, no problem. Well, with the disclaimer that usually converting between doubles and floats lead to numerical problems, but that's something else. If you go from an integer into a float or a double, usually no problem. However, if you go from a double to a float, then you're going to run into problems. Because there's less bits available, there's going to be a lot of changes to your data. If you go from an integer to a byte, again, less information could run into problems. So you're going to have to see whether or not that affects your situation when you actually do those conversions. Now, an interesting topic on character data. So one thing that is not available necessarily by default in C and C++ is working with the Unicode character set. So C and C++ usually works with the ASCII table. ASCII table that defines a specific table that shows you the normal characters. It has some special characters as well. And that ASCII table was developed in the days of your command line. It could only work with things that could display on the command line. That's why it's a very limited set. And back then, it was just English. There wasn't really any other language that was used in the command line. But as time went on, as computers evolved, we needed more characters to be displayed. Different languages, different fonts, all had to be enabled to be displayed. So instead of just working with ASCII, because the ASCII got extended to extended ASCII, and then they said, okay, we need to do something else. And eventually they settled on something called Unicode. So Unicode also had a couple of different versions. And nowadays, you probably use Unicode every single day. How many of you type a message on any sort of social thing and send it? How many? All the people who have hands down are just lazy. Because I guarantee you sent a message somewhere. And in those messages, you probably sent something called emoji. Am I right? Smiley face, winky face, hearts, broken hearts, etc. All of that is Unicode. That's actual character sequence, most of the time too. And now with the Unicode, that the emoji that you can do in different colors, now it's 3 characters long. That is special characters that mean something if the computer knows how to do that. Now, in order for that to work, you have to work with a special sequence of characters. And you'll see there is a char character. Now, characters, usually is just one character. But this is a special thing because you see there's a /u, an escape character indicating that this is a Unicode character. And depending on what numbers you put afterwards, it's a hexadecimal number because you can see there is a B in there, in the example. That will give you different characters. So if you know the actual sequence of numbers to put, you can actually get emoji display on certain places, not necessarily in your terminal, not necessarily in your command line, unless you're running something like Windows Terminal. But you can get special characters appear. So for example, there is an example of the alpha character, Greek letter alpha. Now there are other escape sequences. Some of them you might have seen before. Some of them might be new to you, or maybe you just haven't used them. So /b we don't typically use in normal writing, but it might be available when you are writing a text editor or text processor. Form feed, again, that's something that is in legacy in the ASCII table, but not something that we don't really use very often. The single quote and the double quote, depending on if you're using a string and you want to write a double quote in that string, then you usually have to escape it. The ones you might be familiar with are things like /t for tab. So if you want to tab your output, you can use a /t. And then you have carriage return and line feed. Those are when you press enter, usually that is at the end of your lines. Now, if you're working in Windows, there's both. It's first /r, then it's /n. If you're working in Unix, it's just /r, and if you're working in Mac, it's just /n. Everybody wants to be different. Now, with character data, we do have strings available. We don't have to use char pointers anymore. We don't have to import anything. We have a string class. Now, there is going to be a lecture specifically on strings because strings work differently inside of Java. So now with input and output, we saw we could do output streams by referencing system.out. Now, one thing I didn't mention and one thing I didn't elaborate on is why is there a dot there? What options do you have for referencing something from an instance of class, from an object? What options did you have? You could either do dot, or you could use the arrow operator. If it's a pointer, you did arrow operator. If it's heap allocated, stack allocated, you use dot. If it's heap allocated, you use pointer. So pointer dereference arrow operator. So since we're working with just pointers, and because people didn't want to type in 2 letters when they could just type in 1, Java decided just to use dots for everything. So system is a class. It has something available called out, which is the reference to the output stream. So the output stream has a couple of functions available in it, and they are print. So that will just print something, no new line, nothing. So just print something. Then it has print line, which will then put end of line character. It will go to the next line in your console. And then print line is dependent on the operating system you're working on. If you're working on Windows, it puts /r/n. If you're working in something else, it just puts one of the appropriate ones, depending on the operating system. Then you have something special called printf. And printf is something that, if you're using C, you see that quite often, because that's how you do formatted output. Formatted output works very similar. You specify your string, comma, and then your parameter list that you want to populate into that formatted string. That is the preferred way to output strings instead of using string concatenation. What is string concatenation? More things to put in your classes. Yes. When you need to combine 2 strings. So if you have a string with hello and you have a string with world, you want to put them into one string, you can put a plus and it should combine. However, we'll see that in Java it works, but not in the way you expect it. And we'll talk about that when we get to that lecture. So a better way of putting strings together is by using string formatting. And we'll see examples of those as we do our tutorials. So when we format strings, you can see there is different format specifiers we can use. You can see there's %b, so all of them start with percentage sign, depending on what type you want to use. So B for Boolean, D for decimals, C for characters, so on and so forth. Interesting things you can do is you can also specify a width and a precision. The width is how many characters this will take, regardless of what parameter you pass in. So if you say width 10, if you pass in a number that's only 5 digits, it will still take up 10 characters on the screen. This is nice for aligning things on your screen, especially if you're working with variable lengths. You can also specify a precision. So precision is mostly for things like your floating point values. We can specify how many decimal points you want to show. So .2, I want only 2 decimal points. For .5, only 5 decimal points. Even though your float in memory might show 20, you can tell your string to only show 2 of those. So something we haven't done yet is input. So in C++, how did you do input? cin. You had cin, and you use your stream operators. So cout was for streaming out, cin was for streaming in, out of your program or into your program. So in Java, we have something that is going to be equivalent to our system out. System out references our output stream. So what do you think is the reference for our input stream? System in. In will be our input stream. What's the other stream? You're missing one. What's the other one? File stream. No. Another question for your class test, I assume. error stream. System out, system in, system error. Those are the three streams you are guaranteed to have. So how do I reference them in C++? C out, C in, C error. How do I reference them in Java? System in, system out, system error. So that's how I can get my different streams. Now the error stream is also an output stream, so you can also call print line in print and printf. However, the input stream works a bit differently. We can't use it directly. So what we have to use is something called a scanner class. And the scanner class we're going to use for input streams like system in, but also file input stream. So when we get to talking about files, we'll use that scanner class as well, at least for text files. When we get to binary files, that's going to be a bit different. Now, there is exception handling that we have to take care of when we work with streams. And that's something that you didn't have to really do in C++. If you had C in fail because the user entered something incorrectly, you had some way of getting out of that situation. Or if you didn't care, you just let it carry on and your program crashed. In Java, you have to handle those problems. And you'll see there is an exception that might be thrown, and then we'll have to handle that exception. Now, that's something that we have to discuss in the future after you learn a bit about objects and how they work. So here is a Hello World class with some extra things. So at the top there, you can see something new. Import Java util scanner. Import Java util scanner. So what this is the equivalent of hash include. Hash include scanner. Well, whatever you have, you had something like hash include sys.notify.h. Something like that. You had angle brackets and you had to hash include that thing. So in Java, we don't have hash include. We have imports, we have packages. So that is importing the scanner class that exists in the package called Java util. In C++, you had using namespace. We have something similar here, but in order to reference something in an import statement, you have to write out the full thing. So Java util is the package, and then we have scanner class existing inside of it. Now, all the things in the Java package and sub-packages are all available by default in the language. You don't need to add additional things to it. But if you're using someone else's code, you might need to reference those things. Let the Java compiler know about those things inside of your class path and source path that we talked about on Tuesday. There you can see at the top also, which I forgot to mention, was your inline comments. So // gives you your inline comments. And then you also have block comments. So block comments over multiple lines. Same type of comments you used inside of C++. Then we have an interesting thing going on here, a way to declare a constant. Now in C++, what did you do? Just put constant, everything worked out fine. Now things get tricky. There's two keywords there, static and final. Static, we saw that when we looked at main. You can see there at the bottom, main also on line 14 also has static. Static belongs to a class, not to an instance. So static has to do with where does it belong. Final says that this value cannot change. So that's the way we have constants. This value cannot change. So you can say this variable is final. Once you assign a value to it, no changing it. You try, it will result in a problem at compilation, not even at runtime. So if you look at the main method, you can see it does take one parameter, a string array. You know it's an array because that square brackets, just like C++, means array. Args, and we can process args, and we'll look at processing them in the future. But for now, we're just going to look at doing something inside of this main method. You can see there's an explicit typecast, and that's converting this double into an integer. An integer does not have anything after decimal point. So what's going to happen to it? Get chopped off. If you pass that value of pi into that integer, you're going to get a very humble pi. It's only going to be 3, nothing else. Console output, we've seen how to do that. System out print and print line. So print line will print something, go to the next line. Print will just keep it the cursor on the same line. And there you can see how we can do input. We have to use the scanner class. So we have to create an instance of it. So there on line 22, you can create an instance of our scanner by saying the variable is equal to a new scanner. What do we pass as a parameter? System in. We cannot use system in directly. We have to use it through something like the scanner. Then we can read a line of input. So in this case here, we got something called next line, which will give me a full line of input. There's something called next, which will just give me one word of input. So until I press space. There's also next int, next double, etc. But if your user types in the incorrect information, that's where you run into problems. So if you say next int and the person typing or entering information into your system, they press A, things are not going to go well. So you have to take care when you try and read user input. But if we call that next line, we get a line of information inside of a string, and then we can use that in whatever we need to. Okay, compiling, we already had a look at that on Tuesday, but just it here again. So if we have the file in hello-world.java and we're working in a specific folder, we can call Java C, assuming that we have the JDK setup already. This doesn't tell you anything about the JDK setup. If we have the compiler available, we can compile our source code, and then we can run it with the Java command. All right, any questions before I continue? So the question was, if we can't overload operators, can we perform operations on objects? Yes, why wouldn't you? That's how you did. If you didn't use operator overloading in C++, what did you do? You had instance, method call, pass something in. That's exactly what you're going to do. You can via method call. You can't just do a plus. You can't overload the operators. Yes? I cannot hear a word you're saying. The mask blocks like a lot of things, so you need to protect your voice. Does it save? I can't do it. Does it save automatically? No. No. So if you are working in command prompt, while that window is open, so let me just repeat the question for those online. I'll come check the questions online just in a moment. So the question was, when you're working on the command line, does it save your commands automatically? And the answer is no. While the window's open, you can go back and execute those commands, but they're not saved anyway. If you want to save your commands that execute in specific order, that's what we're doing in a batch file. But if you do any work inside of there, you set a whole bunch of variables, you call a whole bunch of things, whatever operations you do, like you compile something, that file that gets created, obviously that's saved on the hard drive, that's done. But the command you typed out, once you close that terminal, That's gone. That's the whole reason why we're doing things in batch files. All right, so I'm going to check Blackboard quickly. All right, so I see some questions about the import statements and using the asterisk for importing everything. We'll talk about import statements soon. So when we talk about packages, we'll talk about what that means. As I mentioned in yesterday's lecture, and I mentioned it at the end of the lecture, so those of you in class maybe would not have heard me. Some of you might have done a lot of programming in Java before. It's perfectly fine. Don't try and teach your fellow students what you know. That's why I'm here. So you might be able to help them, you might be able to teach them one or two things, but there's a reason why I don't tell everyone everything at the beginning, because it's a lot of information to take in. Especially if you know what's going on, you might think it's easy. But for someone who hasn't done programming before and didn't do so well last year, they need time. So give them time. All right, so let us continue to the next section. Oh, another question? Yes? So line 24 and line 25. So line 24, you can see we're using the variable we declared on, let me just repeat the question for Blackboard. So the question was, what's happening on line 24 and line 25? So on line 22, we declared a variable of type scanner that works around our system in, that allows us to get input from the command line. So just like how you used to do cin in C++, it's the same thing, but we can't use it directly in Java. We have to use the scanner class. So in order to use the scanner class, it has a few methods available. We'll talk about how you can find out where all these things are, what methods are available. We'll talk about that when we talk about documentation. So we're calling a specific method on variable we created. So SE input is our variable that we declared in line 22, and we're calling next line. Next line gets a full line of information, which is whatever the person types, the full line of what they type. So if I type in, I had a good day, it will take that whole thing until I press enter. It will take that and store it into the variable string who, because that method will return a string. Then on line 25, all we're doing is we concatenating two strings, y hello plus whatever the person typed in, and that prints it out onto the console as well. So that's all that's happening there. So I didn't hear what you said. So the next line method, does it take parameter? No, it does not. So again, that, how do I know what function to call, or so what method to call, what's available, what methods? We'll talk about where you can find that information. It's called JavaDoc. There is JavaDoc available for the official Java classes, but we'll see when we get there. All right, so it looks like I am out of time, which is perfectly fine. We'll continue with this lecture tomorrow. If there's anyone with any issues, I'll be here in the front for a few minutes. Otherwise, I'll see you all tomorrow. Just give me a moment. Let me just finish one. Yeah.